My name is Jean-Baptiste, and I'm the president of the VideoLAN nonprofit.
JB, it's so awesome to have you on the show. We are very familiar, of course, with your work and through VLC and all of the projects you're involved in. So I am, really honored actually to be able to talk with you. And why don't you start by, I think everyone's familiar with VideoLAN and with VLC in particular, but give us a really quick history of, how it came to be and yeah.
So people know about VLC, but they don't really know about VideoLAN, and a lot of people mix them, right? And that's okay, right? Because VLC is the most popular part of VideoLAN, but there are other projects of VideoLAN because VideoLAN is a non-profit, and like X264 or David, but a lot of other software which are libraries, and people don't know about them. And all comes down with the history of VideoLAN. The story of VideoLAN is a really weird one because there is no one that decided to do VLC. It's a process that started in the late 80s that did like a few projects that arrived at the thing that was VLC. So how did it start? So at the École Centrale Paris, which is one of the university in south of Paris, the network was managed by the students, and since the 80s. And the students wanted to have a faster network because they wanted to play video games in 1993, 1994. And because the students managed networks, the university didn't want to pay for a network upgrade. So they were like a bit blocked about that. How can we have a new network? And they went to see like a few, because the university didn't want to pay for that, they went to see like a few partners. And they were one partner, which was a TV station, a French TV station called TF1. And they said, well, the future of video is satellite. Okay, well, now we know that it's not, but in 1995, why not, right?
Sure.
And what they wanted is that to be able to stream only with like one satellite dish and one satellite decoder for the 2,000 people who were on the campus, and not have 2,000 dishes and 2,000 satellite decoders. And they wanted to use a network because, well, it was digital, so it should work on the network. And they had this token ring 10 megabit network, which was, of course, not enough. But they said, well, if you do that, we'll pay for the network upgrade. And the students who wanted to play video games say, okay, sure, we'll do that. It seems obvious today, but at the time, like the faster was Pentium 90, and most students had a 486DX at 33 megahertz. So doing MPEG-2 decoding, even in SD real time, like you had those huge cards that costed like hundreds of francs or a few dollars. And that was absolutely not possible, not doable, right? So they discussed about like decoding only once and send raw video with a very small codec and so on. But so this project was like a bit insane, right? 1995, 1996, but they did it. And basically they did this really cool demo for this project, which was called Network 2000. And the project could have stopped there. And actually it did stop there. But after, there was a demo, everything worked, 30 seconds, everything was crashing, everyone was happy. But 1 year after, in 1998, there was a few students who said, well, you know what, like maybe people could use that to stream video on a network. And that's how it became VideoLAN. This was not open source. This was not cross-platform. It took them 2 years to convince the university to change the license of the software to GPL, and they did it in 2001. And based on that, some people who were not at the school, not at the university, one was in England and one was in Netherlands. One ported it to Windows and the other ported it to macOS. But this was just a client, right? The solution was a lot more. There was a server, there was some networking, they did some weird multicast thing on an ATM network and so on. There was lots of part of the VideoLAN solution. And one of it was the VideoLAN client, which was not the most complex at that time. But because it was able to play MPEG-2, someone integrated like DVD playback, and then someone else, added like DivX support. And because it was open source, people started adding new features and so on. And this VideoLAN client became VLC, and like no one cared that much about the whole complete solution. So, and because it was done at the beginning on Linux, where you have the packaging of all together, and it was done by porting a Linux packaging. You didn't use those codec packs, right? So everything was inside the binary on Windows and Mac. And that's how VLC became very popular. And also because VLC was a network player, and is a network player, it was very resistant to errors and broken files. And at that time, when we were downloading things in peer-to-peer, that was very important. So what's interesting is that no one designed VLC to be like, oh, I'm going to do a new player that is going to play everything and it's going to be cross-platform. Because VLC is a small part of the VideoLAN project, which is a small part, the continuation, open source continuation of a project which was like do a new network. Because like in the 1980s, they had a token ring network that was very slow and they wanted to play video games. And because of that, VideoLAN became like first a student group, and in 2003 there was X264 that was started over there, but it's a weird beginning, but then it became a non-profit. But VideoLAN stores a lot of multimedia open source projects.
Interesting. Now, at what point did you get involved?
So actually, I arrived at the École Centrale Paris in 2003. And I was a kind of VP of the network, of the student network. And VideoLAN was actually a part of this non-profit managing the network. And so I started by basically doing broadcasting, mostly on the server side, which was at the beginning VideoLAN server, then VideoLAN client, which was streaming files. And that's how I started with VLC. But I actually spent more time starting in 2005 and 6 when I was actually leaving the school and I was in extremely boring internships where I had nothing to do, and I was just like, hey, what can I do? And so because most of my friends were working on VLC, I was just like, okay, let's do that.
Yeah, let's work on that. Wow, that's amazing. So you started almost 20 years ago, 19 years ago or so?
So after that, I created the VideoLAN nonprofit in 2007, 2008, where I took most of the assets around all the VideoLAN project, VLC being one, but X264 and libDVD CSS and a lot of things. And I started a lot of other projects around the VideoLAN nonprofit, and the VideoLAN nonprofit is doing a lot more than VLC today.
In bootstrapping new codec standards, tell us about David and how that project came to be and what it is. I think our audience knows, but anyway, tell us about David.
So David is this very fast AV1 decoder, but it's one of the most impressive software I know, and people don't realize it, right? So it's basically a collaboration with people from VideoLAN, people from FFmpeg, and people from Two Orioles, which is a company doing VP9 and AV1 encoder. And we were absolutely not happy with the state of the open source format decoders. The VP9 decoder was not as good. And when one became into FFmpeg, it was a lot faster. And there is a good reason for that, because it's extremely difficult to define a new standard and have something that actually works and then something that is production ready, especially because when you look at the energy spent, a lot of the energy spent is on all those machines, right? With the screen and the decoders and so on. So we wanted to have something that was extremely efficient, because we thought it was important, especially because at the beginning, people were fighting against AV1, saying, oh, it's too complex to decode. No one can do that on real time, blah, 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 blah. Things that we heard every time, right? When H.264 was out, I remember, it's going to be too slow. Blah, blah, blah.
Exactly.
When it's going to be too slow. Blah, blah, blah. Oh, AV1 is out, it's going to be slow. Like, come on, guys. Like, you've seen that 5 times. You know how it's going. It's not.
Yes.
But our goal was to say that we wanted to have something that was very quickly there, and like absolutely, like every cycle counts. And because you need to bootstrap somewhere. And it's a chicken and egg problem, right? You don't have hardware decoders, so people don't encode in this format. And because people don't encode in this format, well, they don't because they have no one that is able to play, right? So we thought that having something that was integrated very quickly in VLC and FFmpeg was just like, sure, it's not going to be amazing compared to hardware decoders, but it's going to be quite good. And the result we see today was that in many cases, even for software decoding, sometimes the software decoders are faster and use less power than the hardware decoders for a lot of reasons, right? So the bet, I think, is won. So we launched this project. We had a lot of monetary help from the Alliance for Open Media, who gave the initial money, and then because they thought that we arrived at something that was decent, then we got like extra funding from a few companies directly. But it's people don't realize how insane dAV is, right? So let me explain that. dAV is around 30,000 lines of C. 30,000 lines of C. It's tricky, right? But we're not talking about something so out of line, right? But it's 190,000 line of handwritten assembly. Assembly, right? In 2020, 2021,
I didn't know that.
People are writing assembly by hand. And it's, to give you, there is more assembly in dAV than in the whole FFmpeg for the whole other formats, right?
Wow.
It's insane. Why is that so big? Because we support 5 architectures, ARM v7, ARM v8. We use Intel 32 bits, and which is SSE3, and Intel 64 bits, basically AVX2. But we also support SSE3 with 64 bits because most of the console don't support AVX2. But so that's 5 architectures, and you need to code for them. But then at the same time, you need to support 8-bit decoding. But today, right, like a new codec needs to have 10-bit or 12-bit. And so, well, we have, and like everything that we could accelerate, we did. So it's like, I don't know any software, open source or non-open source, that in the latest few years I've written and has so much assembly, because like even FFmpeg has less, but also that most of it was written in less than 2 years by a couple of people. Right?
So how big? I was going to ask, how big was the team that developed it?
5, 10.
Wow.
Something like that, right?
Yeah. I love it.
And of course, it runs on iOS, Android. Well,
Absolutely.
because like VideoLAN, and because, well, I need it for VLT, right? So by default, it's on all platforms.
Yeah, it has to support all platforms.
Oh, no, this one is small. I don't care. No, we do care, right? VLT is on more platform than Chrome or than Office, right? It's in our DNA, right? So we do that.
That's amazing. I had no idea about all that handwritten assembly. No idea.
And the thing is, like, you talk about handwritten, and every time you speak about handwritten assembly, people are saying, yeah, but you shouldn't do that, right? Because compilers are faster, right? Every single time you hear that, right? And so we've, like, maybe let's try. In average, on many functions, we are 4 to 5 times faster than anything else, even when it's like, we use this version of CLang, so we use this version of GCC or CLang or ICC, and you need to use all those options. We took all those options, right? We are faster. And there was so compared to the original decoder from AOM, which was developed during the process, and this is absolutely normal, right? We are often 3 to 4 times faster, right? We're not talking about 30%; it's just like plus 200%. And the AOM decoder was absolutely not ridiculous, right? It was pretty good compared to what was done on VP9, and people learn about it. But once you have a fixed target, right? Not everything is moving. You can try to get exactly the perfect architecture, and like win every cycle. You can cheat because you know what the specs allows, right?
That's
you know that you know that you like this one is not going to saturate because else the AV1 stream is invalid, so you can cheat there, etc., etc., etc. And there is also the fact that we have the threading on dAV is extremely complex because you have slice threading, frame threading, there is the post-filter threading, and of course the film grain threading. And most people don't, a lot of people who use dAV directly in the software had lots of difficulty setting all those because it depends on the input and so on. So that was done so that you can actually, if you know what you're doing, you can have the maximum power for the software.
Yeah, that's great. I think I love it that you're pointing out the fact that David actually outperforms, or, you made the comment early on that software can outperform even hardware.
Yeah,
And,
so
and
that's a good
let's talk about
question.
that, because I
Yeah, yeah.
think that's counterintuitive. And I think even some of our audience our audience are mostly deep experts, but I don't think everybody either believes that or knows it.
Well, it's because it depends, right? It depends on the
Yeah,
hardware, right? But
that's
especially for
right.
like the problem is that some complex CPUs, because most of the formats, right, they're
Hmm.
on the CPU and GPU, but they are not CPU and GPU, right? It's a DSP,
That's
right?
right.
It's
That's
written
right.
exactly for that. And
Yeah.
sometimes you need to turn it on, and
Yeah.
this turning on this part of the CPU or the
Yeah.
GPU is going to
Yeah.
have like a bigger power, while when you can decode 240p or
That's right.
360p,
That's right.
maybe, like it's going to be similar.
Yeah.
Sometimes it's slower, it's rarely smaller,
Yeah.
but it happens, right? We had
Yeah.
some tests, and then you're going to say, oh, well, it's a bug in the CPU.
Yeah.
Sure, but the
Yeah.
CPU is out, right? It's on the phone. What can you do, right?
Yeah.
It's like
Exactly.
there was a bug. I think it was on Samsung devices where the VP9 decoder on hardware is mismanaging one of the features of
Hmm.
VP9.
Hmm.
So what are you going to do? Well, you disable it, right? Because there is hundreds of million people who have this bug, right?
Yeah.
So we had this case where when you compare, and that was mostly true for lower resolutions,
Hmm.
that sometimes, well, the hardware decoding was drawing more power because it was
Hmm.
turning on another part of the chip, or
Hmm.
big cores, because like it's for lots of reasons, and
Yeah.
that can happen, yes.
Yeah.
um,
Yeah.
but it's
Amazing.
also more important than that, is that to realize that you can achieve, and that's true, it's mostly on lower resolution,
Yeah.
similar consumption
Yeah.
there, and that's pretty cool, because then what's costing you is the backlight of the screen.
Yeah. Yeah, that's right. And this is really interesting. Of course, I spend most of my time professionally day to day on the encoding side, but I'm always happy to talk about decoding, because it's the chicken and the egg, right? So I can create the bit stream, but if you can't play it back anywhere, it doesn't matter. And I know that we get in conversations all the time around AV1 or any new standard. And it always goes like this, with a customer. Yes, we know it's really great. We know it has an advantage. Maybe they've tested, maybe not. But, generally there's acknowledgement like, yes, we're really excited. But come back and talk to us when you've got this ecosystem and that ecosystem, and when Qualcomm is supported and when Apple's supported. They have their long list, right? And we always come back with AV1. What's beautiful, and with David, is we can always come back and say, hey guys, did you know that this player, David, is so powerful and so efficient that AV1 is being deployed on some of the lowest end devices using software decoding in markets that you would think that'd be the last place, that
Yeah,
it's being deployed. And that's
and it's
counterintuitive.
true.
It's
Well, there are cases and in markets where like having a lower bandwidth is so much more important, right? Because
Yes,
infrastructure is not there, or
yes,
because there is a lot of data cap, and because when you have a cell phone, like the biggest consumption of power is your screen and your 4G chip, right?
that's right.
Um,
That's right.
and when you play back video, right? So that's important. And also,
Yeah.
like I envision, and that what I said at the beginning is that you will always need a software decoder as a backup, right? So let's do
Mm-hmm.
one that is efficient when we can
Mm-hmm.
do it. But
Mm-hmm.
what is true is that the amount of time spent on the software decoder is huge, and so it's a lot of resources. Um,
Mm-hmm.
in my opinion. But I
Yeah,
think that the ecosystem needs to do that for every new
it
format, because
does.
if you
It
don't have,
does.
right, and it needs to be on a very liberal license, right? MIT. You want to modify it, like do
Yeah,
it. My goal is that the format is out, right?
yeah.
And I think that to speak about something else, and David, like the VVC project actually understood that for once, right? So the
Mm-hmm.
VVC decoder and encoder that was out of the MPEG VVC consortium
Mm-hmm.
is actually something that is good, right? Not like in HEVC times where you had like something that, well, you couldn't do anything about it, right? So
Yeah,
coming fast on production is important, especially since, well, 85% of the stream are still H.264.
that's right. That's right. Absolutely. Wow. Amazing. Well, so is there anything coming next for David? And what
So
can you tell us?
We released David 1.0 not so long ago. We are fixing a
Mm-hmm.
few stuff. There are a couple of functions that could be faster, and we're working on that. But basically, the main work is done. What we could do, and it's something I would like to do, but currently I don't have the resources to do it, is to start to do a hybrid decoder, which means CPU and GPU.
Mm.
Especially like on David, like if you activate film grain, we give you the pixel shaders that you can run inside your application, so that the pixel shader is applied, the filter is applied on the GPU. And a lot of phones have like very good GPUs, or they're not that good to do complex video games.
Sure.
They're good enough to apply a pixel. And when you see AV1, there are a lot of loop restoration, post filters with the film grain, SGR, Wiener, and so on. And some of those could be offloaded to the GPU. It's absolutely not going to increase the number of FPS. I might think that on many devices, it's going to lower the number of FPS. But as soon as you hit 60 FPS, you don't care, right? But what you could improve is the number of FPS per watt, right? So especially because the filter, which are the last parts of the AV1 decoding process, are very similar on all those pixels. So like GPUs are pretty good at doing that. You could expect that the first part, which is like entropy coding, motion compensation, and so on, is done mostly on the CPU. And at some point in the mid decoding, you will move to GPU. This is extremely rare because most of the time you do either a full GPU decoder, like the one that have been done for OpenGPEG, GPEG 2000, there are many full GPU decoders. Or there was also an AV1, which was doing everything on the GPU. Having a hybrid decoder as open source, I don't think it's ever done. The problem is that here we are not talking about just implementation. We're talking about actually R&D. And we need to have someone, and I don't have the resources on VideoLAN to have someone that, hey, you know what, I'm going to spend 6 months to 1 year having fun. But I think it's necessary for the ecosystem because I think people are changing phone less and less. So the renewal of the machines is going to go slower. Like when I watch my mom with a 5-year-old phone and 6 years old PC, and I say, well, you should change it. She's like, no, it's fine. So having those kind of like hybrid decoding so that you can decrease the power consumption is important.
Yeah, amazing.
So I can't tell you it's next because like currently I'm not sure I'm going to do it, but I think that the next big thing we could do around David.
Yeah. So would you go out and get sponsorship? I mean, it sounds like David was, like you said, it was initially funded from the AOM. And then like a handful of other companies.
Sure. But the founding was mostly like something that is sure, right? They need something, right? So
sure. They have,
like,
that one's
I want
easy.
this, right? Yeah. And when you said, we say, you know what? Like, I would try GPU decoding. Will it work? I think so. Yeah. How do you know?
Yeah.
I think so. Trust me.
We have to build it.
Right. So that's why it's a bit more difficult to find sponsorship and resources.
Got it. Now, so your commercial model, I know you're a nonprofit. So do you literally just, you raise enough money to pay your team and pay the team working on a project, or what does that look like? How does that work?
Exactly. VideoLAN has no money, right? We pay no one.
Yeah. Okay.
So
got it.
There is no business model around VideoLAN. No. Yeah. Right.
And so you're an administrator of these projects.
Yeah, exactly. Right. So, and that allows full independence, right? So that you can
that's right.
And what you see around that, and FFmpeg is the same, right? But what you see around is a few companies which are basically consulting company around that, right? And I created one called Video Labs around VLC. I created one around FFmpeg lately, which is called FF Labs. And and there are a few other people in the community who are either consultant and so on. And because we have those commercial entities, those are able to take contracts. And David was one of the contracts. But it's mostly like it's the outlier. Most of the time, it doesn't happen like that. But
yeah,
of course, if you want to have something that is like extremely focused, like David, and like in 1 year and a half have a decoder, and 2 years have the fastest decoder ever,
sure.
then of course you need resources, and then you use those kind of very common thing you see on open source, which is commercial company who works.
That's right.
And there is a lot of people around the VideoLAN FFmpeg community who actually do that.
Got it. Got it. Wow. Amazing. Well, thank you for giving all the details behind David. You know, I started out by saying that, you know, I wanted to talk about David. I also wanted to talk, maybe have a little more sort of philosophical type conversation, not really philosophical, but to say that it's so important for a new codec standard that this role of having an open source, highly performant decoder, you know, that really works, because without that, you know, you can have the greatest encoders. It can be a really great standard, but it's ultimately going to fail because you can't play back the bit stream, you know.
And you need at the beginning to have a decoder that works everywhere, because
that's right.
It's like you have like an ecosystem, and like not everyone has the same type of platforms, but like if you want to reach out, you need to have everything, especially since, like, let's be honest, H.264 was amazing, right? When you move from MPEG 2, and then what, right? Oh, what is it good with HEVC? Well, it's great for 4K. I don't have a 4K screen. I don't care, right? So you need to, it's like when you move from VHS to DVD, right? Like the change was in usage was huge, right? When you change from DVD from Blu-rays, what is a Blu-ray? Well, it's a DVD extra HD, right? That's it. That's how you define it.
Yeah.
But having DVDs where you have chapters, like multiple videos, multiple angles, you don't have to rewind your VHS. Yeah. And that's the same what that happened with H.264. H.264 was like a huge leap. And then you need to be a ton better, right? To change it. And for example, HVC completely failed. It's it's an error. And of course, people from MPEG are mentioning, no, it's great, it's great. Yeah. It's a complete failure. It's a complete failure compared to the amount of money that was invested.
That's right. That's right.
Even in open source, right? VP8 or VP9 did not get the traction they should have had, right? AV1 is, in my opinion, the continuation and learn about the issues that they were. But it's important because you need everyone to be able to play your streams, because then it costs money on networking, on encoding time, on storage, and so on. So right, so it decoders. And today it's quite funny, right? Because there is VVC, AV1, sometimes in a few years AV2. You have MPEG EVC, which is like the low version of VVC, but it's also baseline and not baseline, which is confusing. And then you get the MPEG 5 LC EVC, which is not really a codec, but it's a codec that is actually an enhancement layer over all the codecs. And so like, are you going to build all those inside your DSPs on your chips? Are you going to waste 1 billion transistor on each of those formats? What about encoding, right? When are you going to drop MPEG-2 decoding in hardware or encoder in hardware, right? Right. So those trade-offs are important, and you have to fix your licensing, right? So sure. If you don't, then you get the HEVC problem. But you need to have very good decoders. And for example, on HEVC, it's fun, but the FFmpeg HEVC decoder is in many cases slower and less good than the AV1 because we spent less time on it. Right?
That's right.
So
that's right.
If you want your format to be popular, and you don't care about piracy, you don't care about UGC content, you don't care, but those people are the ones who are going to buy your devices and make it out, right? And you are not alone, right? There are many formats, so you need to compete.
Thank you so much for coming on. And I know that we're going to do a part 2. So I'm really super excited to hear about the projects that you have coming up. But this concludes the David discussion. And thank you again. Thank you, JB.
Thanks a lot.